All right, guys, let's take a look at section 4.3, and we're still looking at logarithms and how to work with logarithms. In this section, we're going to look at expanding logarithms. And we have several properties we're going to use. Now, we're still going to use the ones we had the other day, the identity rules and the inverse rules. And of course, the definition still applies, but we're not going to use that quite as much in this section. But now we're going to add a few other rules to our repertoire. The product rule says that if you have the log, it doesn't matter what the base is, but if you have a log and you're multiplying two things together in the argument, if you want to separate that or expand that into two different logs, you can use addition. So in other words, log base b of m times n can be separated into log base b of m plus log base b of n. The quotient rule says that if you're dividing something in an argument, log base b of m divided by n, that can be separated as log base b of m minus log base b of n. And then the power rule says that if you have log base b of m raised to a power, you can simplify that or expand that by bringing that power to the front of the log and writing it as p times the log base b of m, if p is the power. And there's one more called change of base. We're going to come back to that one a little bit later on. But those three that we just talked about are the main ones we're going to use to expand these logarithms. If you do go on to calculus or something higher level later on, it will help you to know these properties, and it'll make the work easier sometimes if these are in expanded form, and that's why we do them in this class. So example 1, it says expand the logarithm expression into multiple logarithms. How do you know when you're done? There should be no more products, powers, quotients, or if there's a radical in the argument, then it's completely expanded. Simplify any numbers that you can simplify. So let's look at some examples. Letter A, we have log base 4 of 35. Not a whole lot we can do with that. We're not multiplying anything like that or dividing anything, but can we write 35 as maybe a product of two numbers? So the first that come to mind for me are 5 and 7. So I'm going to write this as log base 4 of 5 times 7. And because that's multiplication, I can separate it into two separate logs using the power rule. The product rule. Log base b of m times n can change to log base b of m plus log base b of n. So if I apply that to this problem, this turns into log base 4 of 5 plus log base 4 of 7. And that's as expanded as we can get. 5 we can't write as a power of 4. 7 we can't write as a power of 4 because 4 is the base. Nothing else is being multiplied or raised to a power or anything like that. So this is completely expanded into separate logarithms. Let's try letter B. We have log of 10 times x. So you notice we're multiplying two things in the argument, the 10 and the x. So again, we can use that product rule and separate this into addition of two logs. So I'm going to write this as log of 10 plus log of x. So I've taken care of separating using the product rule. If you notice that we have a common log here, the base, remember, when there's nothing written as an implied base 10, we said that was the common log. So this is really log base 10, and it's 10 for both. But the reason I bring that up is if you can simplify using the properties we used in the last lesson, if you can simplify any of the numbers, go ahead and do that. Log base 10 of 10 using our identity rule, remember log base b of b equals 1. So how does that apply to log base 10 of 10? We can replace that with 1. So this turns into 1 plus log of x. And I'm not going to write the 10 there because it's not necessary. It'd be okay if you did, but it's not necessary. So that's completely expanded. Let's try letter C. We have log base 7 of 19 divided by x. So since we're dividing something, we're going to use the quotient rule to separate it using subtraction. So I'm going to write this as the subtraction of two logs. So we get log base 7 of 19 minus log base 7 of x. And I don't see anything else I can do with that. 19 is a prime number. It can't be broken down at all. It can't be written as a power of 7. And then I just have an x there. So that's as far as that can go. Let's try letter D. We have natural log of e to the third divided by 7. So again, it's being divided, so we can separate it using that quotient rule. And so we'll write it as the natural log of e to the third minus the natural log of 7. And just like the one above it, anytime you can simplify to a number, you want to go ahead and do that. Natural log of e to the third, remember our inverse rule from back here, log base b of b to the x just left you with x. That applies here because what is the base for natural log? Remember, that's base e. So natural log of e to the third will just simplify to 3. So we have 3 minus the natural log of 7, and that's completely expanded. All right, so let's take a look at example 2. The directions are the same. They want us to fully expand the logarithmic expression. So part A, we have log base 5 of 7 to the 4th. I don't see anything being multiplied. I do, however, see that we have something raised to a power. Now, if the 7 were a 5, we could use the inverse property that we talked about the other day. But it's not. It's not a power of 5 or anything like that. The only thing I can do is apply the power rule. So remember the power rule just a second ago that we had said that if we have something raised to a power, we can put it in the front of the logarithm, and that would be expanded. So how does that apply to this question? We can take the 4, the power of 4, and move it to the front of the log. So we'll write this as 4 times the log base 5 of 7, and that's completely expanded. Can't do anything else with that. Letter B, we have the natural log of the square root of x. So when you're working with these expanding problems, if you see a radical, this is a very important thing to remember. If you see a radical like this, the first thing you want to do is write the radical as an exponent. So remember earlier in the course we said that if you have the nth root of x to the m power, we could write that as an exponent by writing it as x to the m over n. Remember that from way back in chapter P. We said we're going to use that a few times, and here it is. So, for example, if I have the square root of x, remember there's an implied 2 on the outside, an implied 1 there. So the square root of x is x to the 1/2 power. We had one like that in the last video. We had 25 to the 1/2 power. Remember, was the square root of 25. Same thing here. So I have natural log of the square root of x. That can be rewritten as natural log of x to the 1/2 power. And then, since we have an exponent, we can apply that power rule and put the 1/2 in the front. So we have 1/2 times the natural log of x. So when you're expanding these, anytime you have a radical, change it to an exponent and then move the exponent to the front to be fully expanded. There should not be any radicals when you expand. Let's look at letter C. How does that apply? We have log base b of x squared times the square root of y. So our argument is x squared times the square root of y. First thing I would do is separate those using the product rule, because I'm multiplying x squared and the square root of y. So I'm going to write this as log base b of x squared plus log base b of the square root of y. So that's our first step. Next thing I would do is get rid of the radical. We can't have the radical in there when we expand. So I'm going to write this as log base b of x squared plus log base b of y to the 1/2 power, because it's a square root. Last rule then is to take care of any powers that you might have. So you see that we have a power of 2 that needs to go to the front of that respective log, and a power of 1/2 needs to go to the front of that log. So we have 2 times log base b of x plus 1/2 times log base b of y, and that's fully expanded because we don't have anything else being multiplied or divided or raised to a power in either argument, so it's completely expanded. Last example here, we've got log base 6 of the cube root of x divided by 36y to the 4th. So I would go ahead and take care of the division, the quotient, using the quotient rule first. I'm dividing something, so let's separate that into separate logs by using subtraction. So this becomes log base 6 of the cube root of x minus log base 6 of 36y to the 4th. Now you notice we have something being multiplied, the 36 times the y to the 4th, so we can expand that using addition. So let's rewrite the whole thing. We have log base 6 of the cube root of x minus log base 6 of 36 plus log base 6 of y to the 4th. And you have to be a little bit careful here. We changed the 36 and the y to the 4th into addition of 2 separate logs using the product rule. However, the 36 and the y to the 4th were originally in the denominator. So this minus sign, when we expand them, has to apply to both of these logs. So I'm going to put parentheses around it to make sure I remember to distribute that negative to both of those log terms. Next thing I would do is go ahead and get rid of that radical. Let's write the cube root of x as an exponent. So this will be log base 6. Remember, this is a 1 is the exponent, cube root of x to the 1st. So that becomes x to the 1/3 power minus, I'm going to go ahead and distribute this negative sign, log base 6 of 36 minus log base 6 of y to the 4th. Next thing I would do is get rid of the powers. So the 1/3 will go to the front of the first log. Minus, now do you notice, while we're at it here, 36 can be simplified because the base is a 6 there, right? So if you can simplify according to the base, let's do that. So that becomes log base 6 of 6 squared. Remember, if you can rewrite that argument as a power of whatever the base is, you want to go ahead and do that. Minus 4 times log base 6 of y. Almost done. If you can simplify an expression into a number, that log base 6 of 6 squared can be simplified. What does that simplify to? So we have 1/3 log base 6 of x minus 2, right? Log base 6 of 6 squared simplifies to 2 minus 4 times log base 6 of y. And that's completely expanded. You can see we're not multiplying anything, we're not dividing anything, we're not raising anything to a power inside any of the logs.